My name is Hariharan. Everyone can call me Hari. I'm a postdoc at Livermore working with Catherine Moore, and this work is in collaboration with Gertrude from the HDF group. And I think it's a very timely talk because the last two talks have been on applications and people have been asking about what do you mean by zones, what do you mean by blob? And kind of this talk is on that same notion of how does systems people understand applications better. So the title of this talk is Towards Autotuning HDF5 with User Intent. Users here are applications, essentially. So let's talk a little bit about user intent. What I've seen while talking to people, systems, as well as applications is user intent, everyone understands, but no one defines it, and it's very implicit in nature. So if we want to talk about it, exactly what it is, in a way, it has these three words. Why, what, and how user performs certain AI operations. And just to give an example of what user intents are, I think as an application developer, most people kind of understand what user intents are, but sometimes when that gets translated, when they look at a software, maybe they look at configurations and not user intent. So I wanted to draw some examples here just to make that distinction clear so that the rest of the presentation is a little bit clearer. So as an example, for instance, if you're talking about an HDF5 file as the what, user intent could be that I want to checkpoint a process, maybe like file per process using zones. But what we generally, when we look at HDF library or any other software, we think about, oh, I probably need to cache this file, or probably need to do chunk caching. A similar example from POSIX could be reading samples from file, typically what AI does, and you have 32 samples per file from 1,024 files with MPIO. And in this context, again, configurations which are mistreated as user intent could be preloading data and using staging interface, staging interface of burst buffers, right? And when you think of intents, they don't just apply to the HDF layer or the MPIO layer or POSIX, they apply to everything. So we have to think about how a user's intent is trickling down through our storage stack and reaching the storage system eventually. In terms of how does that user intents look within our world, if you look at scientific simulations, we are talking about a write heavy with collective IO and sequential patterns. We are looking from on data analytics, we're looking at write once, read many, file per process, and random. From AI, we're looking at read heavy, collective, or file per process, depending upon which data format you end up using and whether it's sequential and random. And if you look at multi-stage workflows, which are becoming very common, how do consumer producers share data? Are they doing file per process? Are they doing sequentially or randomly, so on and so forth? And as you see, there is a lot of changing IO intents. And as you go into more and more workflows where multiple types of applications work together, this becomes even more complex. Now, HDF library honestly has a lot of ways that they can tune applications. But as you can see here, it's a big list. So if you just look at the titles here, you could think about reducing IO. You could think about aligning IO with storage. You could think about data caching. You can think about collective IO. You could think about doing in situ operations. And you can do all these things. There are about 200 properties within HDF5 that you could potentially look at. And there are, through research and development and a lot of numbers, there are a lot of benefits of using these in a wide variety of use cases. So on the left, we have what the applications want, which is, oh, I want to do file per process on a data set and in a particular way. And on the right side, we have a bunch of configurations through property lists. And my PhD is kind of into this and contributes to this, that there is a mismatch because we tend to, whenever our conversations happens with applications people, this is what we're trying to do, is we are trying to figure out how their use cases match to what we have built. And so this work essentially tries to say, okay, can we, instead of looking at configurations within HDF5, can we look at the use cases directly as higher level IO intents? And so in this work, we are building a virtual object layer wall, which everyone here knows. which converts these user intents into HDF5 configurations automatically, and hence the auto-tuning part of it. So going briefly into this, and we can go into more details if someone wants to talk about this a little bit, but in a way, the high-level design consists of two main parts, the offline and the online. The offline part basically looks at what the application is doing now. Actually, we have done more work on this in terms of building APIs. It's called Mirror. So what we found out there was it is very hard for even applications to sometimes go and change their applications. So for legacy applications, you could look at a high-level Darshan profile and extract some of these IO intents yourself. So in this work, we kind of allow you to do both. If you're an advanced user, you can tell us through property list APIs, what are your IO intents? But if you want to go the other route and kind of let us discover, we have built tools to kind of generate those intents out of your application. And then the runtime part of it is basically the HDF5Intent wall, which looks at these intents and uses an heuristic rule engine right now to apply the appropriate configurations. Now, even as a person working on HDF5 for 7 years, this was a lot of benchmarking I had to do to figure out how to use a lot of these property lists myself for different use cases. So it's a hard job. So what we did here was we built a rule engine which can kind of take some of these use cases and demonstrate the benefit of doing this. Just as a little bit of example of what we are looking at, the IO behaviors, for instance, we are looking at from Darshan's high-level tracing is, for instance, we are looking at multi-session, like the close and open timestamps. We are looking at access patterns. We are looking at access of elements. We are looking at bytes read and written. We are looking at size of file before and after the write, before and after the application ran, or how many ranks in a way are processed in the data set. These get converted into a smaller set of IO intents or use cases. This is a very small list of things that you could do with this. I'm writing a paper on this and it's ongoing work, so any feedback is highly appreciated. But what we're talking about here is thinking about multi-session IO. Like we are trying to have these HDF5D open and close epochs and within the application. We're talking about that kind of stuff. We're talking about what are our transfer side distributions. Are we doing write only, read only, or a mixed kind of a pattern? What is the approximate size on file? And how are we going to share the file among processes? And that gets automatically translated into the real engines into different property lists, basically. A little bit of initial testing. What we did was we used the VPIC IO kernel and we extracted IO intents. And from those IO intents, we did the following. The rule engine basically spells out these HDF5 configurations. Most of you probably know these, and so I'm not going to go into details. If someone has questions, I can go more. But the basic idea here is that just using intents can help us through the wall achieve up to even 12x better performance as you scale the application. And so you can actually reduce a lot of the write cost in this application. Just as a thought process, who would be beneficial with this work, right? So HPC users who are trying to use HDF5 for high performance, right? A lot of the talks before this was talking about that, and seems like the rest of the sessions are going to be like that too. So we're talking about better performance for those applications. We're talking about reducing complexity of configuring HDF5. Is how can I use HDF5 with the least amount of work and better. We're talking about HDF library. In terms of HDF library, we can make the property list a little bit more user-centric. And also from the storage system perspective, we can have more predictable, stable IO across applications. I had a small demo, which I had in practice, but the systems are down and it's on a different laptop, so I can't do that. So I'm going to give you a few slides about this. So these work. So through H5Intent, you can actually run a script, get the Darshan. But this is typically what all it is doing is LD preloading Darshan, running with H5Bench and getting a Darshan file out of it. From these Darshan file, we can basically generate intents. This is a Python script in the back of the script. And then once you do that, you kind of in 4 seconds, in this case, it's a 4-node test with 160 processes doing file per process pattern. And so you get an intent file for your particular application. And kind of this is how it looks. As I said, it's file per process. So every rank has its own HDF5 file. And in every HDF5 file, you have all the intents. I kind of talked about it before. And then you have also data sets after this, which I'm not sure it's too many of them. But yeah, so that's kind of how it is structured. And then we did I was just trying to show a simple test case where I just run H5 as is in vanilla. You can run it, you get your results through H5 bench. And then when you load up the intent-based stuff, as you can see here, basically what we did in this example was to demonstrate that for file per process and files that fit in memory, you could probably just use a core VFT out of the box and improve your raw write performance and eventually speed up the application. So, one time. I'm early. Very good. So, okay, so questions. And as I said, this is ongoing work. So if anyone has feedback, questions, or improvement for the work, we're happy to work and integrate your configurations as intents into the HDF library. Thank you. Okay, that's good. More questions?
Where was the microphone?
You could use this.
Well, I'm going to. Can you analyze intent? Because intent can be wrong, right? So user has intent to write for some reason because he does or she doesn't or she doesn't. How to organize data and writing one byte per data set, using on data sets instead of writing one big data set.
Yes.
So following the user and not analyzing what the problem they're trying to solve, which is.
So let me flip it for you.
Okay.
Right? Where now, if I gave you that intent of saying a very bad access pattern for HDF5, HDF5 like now throws errors saying or warning saying, oh, you're doing something weird with this configuration. This is not even getting applied. You could throw the same thing here. The idea here is not about what intent they pass, is the about of having the knowledge of what they're trying to do. They might be trying to do stupid and foolish things, and we could, as a library, be smarter at that. Does that make sense?
Yeah, it does make sense, but it goes back to.
Yeah, it's a chicken egg problem. Yeah, I agree.
Tuning to me implies that you have some goal to be optimized. A lot of the cases that I work with, we have multiple goals to be optimized. So, for example, we want to write files that are as small as possible, but we also want to write them as fast as possible, and we want to have as little data in memory as possible, and all of these things are antagonistic with each other.
Yep.
So, does your work support having kind of a multi-objective?
Perfect. So kind of this slide tries to talk about that. Now, honestly, till now, we have not got into anything but performance because performance seems to be kind of something everyone agrees upon that they want. But at the same time, I agree with you. There are a lot of features within HDF5 that reduce I/O through compressions. There are a lot of other things you can do, like, for instance, better usability of doing filters on what data you really need to keep. Like in your case, where only one interaction happens in so much of data, you could apply a filter before actually even storing the data, right? And so we could do a lot of cool things within HDF5, which might not be performance directly. But the idea here is to still figure out what cases apply to you who's trying to do that I/O, right? And kind of try to have that common language of intent between the applications and the software who's trying to manage data for that application.
Question on the performance. Do you have a way of measuring, like, what is the upper bound of the best performance you could get? And I don't know if that is for a given intent, what is the best you can get, or maybe what is the best you can get if you had the smartest intent, but I mean, you gave some numbers that said you could do 8 or 12 times better or something. I'm wondering what is the best that we could do. How do you measure that? Have you thought about that?
So,
your thoughts?
As building middleware libraries for I/O, I think for us, we are always trying to get memory performance as much as we can. If you look at pure memory operations of that system, honestly, that's my upper bound that I'm trying to reach, no matter if it's HDF5 or not. And so the idea here, at least in those use cases, was how can I efficiently cache things into memory or aggregate things into memory before I actually have to move it down asynchronously. So as much as we can hide the I/O cost is the more the performance in that sense. And so it's subjective to the system, honestly. But for the use cases, as I said here, what we essentially ended up doing was a lot of these, as I said, there are 200 of these configurations. So you can think about benchmarking 200, first of all, and then a lot of them don't work together. And then they work opposite to each other in certain cases. And so you have to kind of be an expert in terms of how to configure. So the idea here is to use intents to build better use cases of what we support, and then use those to configure the system better. But yeah, as I said, we're trying to essentially try to have as much memory performance as possible as the upper bound for all these cases, if possible.
Hey, Rick. This is very cool. And it leads me into the maybe 3 sort of interrelated things. It's going to be longer than 50 questions here. Are there any properties that are like, everybody needs this? This should be on all the time. What kind of discoveries has the system actually made? And, you know, conversely, are you trying to like come up the typical automobile versus horse kind of race, right? If you compare the configuration to an expert level configuration of a by hand version of something where, you know, I played with this by hand and I know this is the best I can do. And then thirdly, what's missing? What properties can you discover a property that would actually say, you know, there's no way to tune this stupid thing, but if I tune this stupid thing, I can make this go better.
So a couple of things I found useful for my benchmarking, let's say, which was basically trying to a simple use case of transfer sizes, right? We're trying to do different kinds of access patterns through transfer sizes and trying to look at small accesses like AI does, maybe data analytics does, random, trying to look at other kind of access pattern. I think chunked IO to me helped a lot in a lot of these cases because it kind of stops applications from doing stupid things in a way. And if you correctly do your chunk cache, you can kind of make sure you're not doing really bad IO on the file system. I think that's useful in my opinion. However, if the file is already written, you can't do much about it. And so then you can maybe say, oh, maybe you should regenerate your set with chunk layout, probably as an intent, right? If you had an intent of small accesses, maybe a pattern that you recognize. In here, what we actually found out, it's the other way around to think about it, Quincy, is HDF5, all these property lists were built for a purpose. And intents are those purposes. So my conversation with Gert was, why was this even made? And why was this even there? And it's for historical reasons was the first answer. And then he would go and figure out, oh, this was built for this use case. And then I would go and test that use case to figure out, oh, okay, it works now. You see what I'm saying? So it's that mismatch between what does this mean? Because no one understands HDF5 better than HDF5 group, but then no one else really understands any of these properties because of that. And so what I'm saying is we should be more application-centric as softwares. And then we can kind of tune and say, okay, for these use cases, we can optimize you. For these use cases, we cannot. And
what are the discovery there? What needs to be tuned?
So in this case, I did not look at new configurations, honestly. I was looking at how to even use the 200 that I have. And it was a daunting task, honestly, to wrap your head around them. But hopefully in the future, if we have enough of these use cases, maybe we will be having overlap with existing use cases and new use cases which come up. And we can then figure out if we are missing some tune or knobs for those use cases. But I think it's a more structured way of thinking about it than anything else.
We have one more question.
Hi, first of all, thank you so much for your talk. It was really interesting. And following up like this topic, is it possible to use your tool to analyze the I/O pattern of applications that doesn't use HDF5?
Good question. So I actually built this for POSIX first in the past. As you can imagine, the lesser the amount of configurations a layer has or semantic it has, the lesser the intent, right? And so it kind of depends upon what access patterns you're looking at. But yeah, I do have a tool for the previous paper that I wrote was Mimir. It was just published in IPTPS. So there is a tool which works with POSIX and looks at certain aspects of IO access patterns. So you can probably use that for other applications. Yeah.
So,
Thank you.
thank you very much.